So in 3.4, using elementary transformation, we are asked to find out the inverse of the matrices, if it exists. Okay, there are a few things that you have to know. Let's say that A is any matrix. A is any matrix of order M. Let's say it has order M, a square matrix. See, if it is a rectangular matrix, 1, 2, 3, 4, 5, 1. Let's see, if it is a rectangular matrix, then this matrix has 2 rows and 3 columns, right? Then we say the order is 2 cross 3. Order is 2 cross 3. But if we are talking about a square matrix, 1, 2, 4, 1. If we are talking about a square matrix, then the number of rows should be equal to the number of columns. Number of rows is 2, number of columns is 2. So this is a 2 cross 2 matrix because number of rows is 2, number of columns is 2. So number of rows and number of columns are equal. So it is a square matrix. So instead of saying it has order 2 cross 2, you can say it has order 2. Alright? You can say it has order. Order is 2. Instead of saying 2 cross 2. But for a rectangular matrix, the number of rows and columns are not equal. So in that case, you have to say 2 cross 3 matrix, 3 cross 1 matrix, 4 cross 3 matrix, okay? Alright. In general, for a rectangular matrix, the order will be M cross N, where the number of rows and columns are different. But for a square matrix, since the number of rows and columns are equal, suppose if it has M rows, then it must have M columns. So instead of saying M cross M, you can say the order is M. Alright? So for a okay, so that is how we say about the order. So I'm going to say that suppose A is any square matrix. Square matrix. So of order say M. Instead of saying M cross M, I'll say only M, okay? Now suppose A is any matrix of order M. Order M means it has M number of rows, M number of columns, so square matrix. Now, if there exist, this is the symbol of there exist. In maths we use some certain symbols, right? Belongs to, B-E-L-O-N-G-S, belongs to, like this. Huh? So the same way, okay? There exist. So if we can find, or if there exists another matrix B, for this matrix, suppose A is any matrix of order M. Now if we can find another matrix, or if there exists another matrix B of same order, means M, order should be M, such that it satisfies this condition. A times B is equal to B times A, and it is equal to your identity matrix. Are you following that? No? Yeah. If you, for this A, if you can find another matrix, okay, or if there exists another matrix B of same order, such that A times B is same as B times A, and their product is equal to your identity matrix. If A times B is your identity matrix, or B times A is also your identity matrix, then in that case B is called the inverse of A. In that case B is called the inverse of A. That means A inverse is there, and that is B. Then we say that A is invertible. It means A inverse to AC. Okay, AC? Matrix B to AC. Is it okay? But if A is a rectangular matrix, okay, if the order of A is M cross N type, if it is a rectangular matrix, then inverse does not exist. Because for a rectangular matrix, A times B or B times A may not be defined. Okay, for some it may be defined, but in general, A times B, okay, A times B or B times A may not be defined. In that case, A cannot be invertible. Alright? So for a rectangular matrix, in general, inverse does not exist. For a square matrix, it exists. Is it okay? Are you following that? Yes. Now we are asked to use this elementary transformation. Elementary transformation means you can do row transformation and or not and, okay, not together at the same time, or COLUM, column transformation. Elementary transformation means row transformation or column transformation. So there are few rules that we need to know. There are 6 rules. There are 6 properties. 3 rules for rows and 3 for column. Okay, same. The first one is you can interchange any 2 rows or you can interchange any 2 columns. Okay, it is possible to interchange any 2 rows or any 2 columns. Okay, that means you can interchange. Suppose you are talking about a 3 cross 3 matrix. Okay, then you can interchange row 1 and row 3. This is how you have to write. This is how you have to write. Row 1 goes to row 3 and row 3 goes to row 1. Now, in chemistry also, while doing the reaction, if the reaction, what do you say? Suppose the reaction can go back to its previous state, no? Then we write like this, right? Reversible, yeah, if it is a reversible reaction, then this is how you can, this is how you write, right? No? So the same way I can write like this. R1 goes to R3, R3 goes to, I can write like this, like a reversible reaction. Instead of writing 2 arrows and saving more time, in maths is anything which is precise and compact. So we write like this. Okay, with double arrowheads. Yeah. Or you can interchange any 2 columns. Okay, you can interchange the first column and the second column. You can interchange the second column and the third column. You can interchange the first column and the third column. Anything is possible. Okay, so interchanging of any 2 rows or any 2 columns is possible. Second one is you can multiply any row or any column by any non-zero scalar. Multiplication of any row or column by a non-zero scalar. Multiplication of any row or column by a non-zero scalar. I will give you some example. Row 1, okay, suppose you can multiply row 1 by any number, any non-zero, by any non-zero scalar, by any non-zero real, okay, real number. Suppose you want to transform C3, you can multiply C3 by any scalar, non-zero scalar. Multiplication holds for division also. You can also divide. In general, I'm saying only multiplication. You can divide any row or any column by a non-zero scalar. Example, suppose you want to divide R2. You want to divide R2 by 5. Then I can convert that to multiplication. R2 goes for 1 by 5 R2C. It's multiplying, right? Is it okay? Dividing is okay. We can make in terms of multiplication. So we used here only multiplication. The third one, this is the second one. Third one is just the normal operations that we are using. Adding to the elements, or addition to the elements of any row or column. The corresponding elements of any other row or column multiplication by a non-zero scalar. Is it okay? Suppose I'll show you an example. Suppose this is 1, 2, 2, 4. Let's say 1, 2, 2, and 5. Okay. Now this is your row 1. This is your row 2. I want to convert the first element of row 2 to 0. Huh? This is the first element of row 2. I want to convert this entry of row 2. We cannot say this as the first element, okay? I want to convert this entry of row 2 to 0. Then what kind of transformation I can use? Since I want to convert this entry of row 2 to 0, so row 2 should undergo some transformation. What kind of transformation? What I can do? I can multiply the neighboring rows by any non-zero scalar, right? Is it okay? So what I can do is, I'm going to simply multiply row 1 by non-zero scalar 2, and I'm going to subtract from this row 2. Now, I'm going to multiply row 1 by any non-zero scalar and subtract or add it from row 2. Then in that case, this entry will become 0. That's what the third one means. Is it okay? Addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by a non-zero scalar. Is it okay? So all these kinds of transformation are possible. Suppose you have a matrix 1, 4, 2, say this is 2, let's say 6. Now I want to convert this entry of column 1. Let me do some column operations here. This is I want to convert this entry of first column to 0. Then what I can do is, C1 has to undergo some transformation. What I'm going to do? I'm going to multiply, since this entry belongs to C1, I'm going to multiply C1 by a non-zero scalar 3 and subtract it with C2. Huh? Then what happens? This entry becomes 3 times 2 minus 6. This entry becomes now 0. Is it okay? So adding to the elements of any row and column, the corresponding elements of any other row or column multiplied by a non-zero scalar. So these are the 3 types of transformation. 3 for rows, the same 3 for columns. So altogether there are 6 types of transformations that you can use. Alright? Okay. So this is a brief introduction only. Alright? Actually this should have been the first introduction, but it's okay. We have already solved some of the questions. Now I want to solve some more from 2 cross 2 matrix. Suppose I want to solve number 10. Exercise 3.4, number 10. Let A be your given matrix. Your given matrix is 3, minus 1, minus 4, 2. So this is your given matrix. I've taken it to be A. So I want to find out A inverse if it exists. Now, we know that any matrix A can be written as identity matrix times A, right? Now your matrix A is 3, minus 1, minus 4, 2. I is your identity matrix of order 2, 1, 0, 0, 1 times A. I need not repeat writing it again. Okay, we need not do that. Now we have to convert this matrix on the left hand side to be equal to identity matrix, right? 이두개의 identity matrix 번호니. 이두 identity matrix 나. 또 first 키 그리고 last row라가 first last row게 이두 transformation बना이 되보니. 나? The entry of this, all the entries of row 2, okay, should be equal to this now. मतलब the entry इतो -4 की बनाबो 0 बनाबो इतो की बनाबो 1 बनाबो ना इतो रो 2 के इतो दी कन्वर्ट नो करेगे ना रो 1 के स्टार्ट करबो ना पारिनी इज इट ओके इनागा ट्रांसफॉर्मेशन तो किदे भी नहो फर्स्ट की करिबो रो 2 के इतो लगा इक्विवेलेंट बनाबो इतो बिचदी रो 1 के इतो लगा इक्विवेलेंट बनाबो इज इट ओके तो रो 2 के okay, first itu entry row 2 laga itu entry ke 0 banabo row 2 laga itu entry ke 1 banabo no hoile bi first itu entry du ki banabo itu ke first 0 banabo lage on the next step only itu ke 1 banabo itu bichide itu entry ke 0 banabo aru last eta hi itu entry ke 1 banabo ta last hobo khodai last the last year then there. Okay? Are the frontline soldiers as Moriwo first time. Okay. Okay, to ki koribo? Idu ke 0 banabole munaze. Tai row 2 diaze. Na. So row 2 ke transformation padabodo. Row 2 du kinaga transformation dibo. row 2 ge kinaga transformation dile tai 0 banao 0 banabo koila ami khan neighboring row ge use koribo do hena noy to tai la neighboring row to row 1 ni ase do na hena noy to tai la corresponding element row 1 ti sabe itu isati operation to banabo to ki koribo itu entry row 2 ge ki bra multiply koribo 3 bra multiply koribo opposite sign ase to addition hobo lage aru ki koribo row 1 laga elements ke row 1 ke 4 bra multiply kori dibo na to ki hobo ido nai ido r1 do iko transformation nai bodo no transformation in r1 only r2 so this will now become 3 into -4 is -12 12 plus 4 into the corresponding element in your R1 is 3. Yeah. So -12 plus 4, 3 times is 12. -12 plus 12 to kima nobo? 0. Now we should Tai give transforming operation halibodo. 3 2 times is 6 plus 4 into tai la corresponding R1 do -1 na 4 into -1. So -4. 6 minus 4. Same as so whatever operation you have performed here, the same operation has to be followed here. Taido 1, taido 0 na. To tai kyubo. Yeah. So 3 times 0 to 0 will 0 plus 4 times 1. 4. Okay. And then 3 times 1 is 3 plus 4 into 0. 3 over times. So this has become equivalent to this. Now equal first row 2 laga hi itu ke banabo do na. Tai do 0 hoise itu entry ke ki banabo lage 1 banabo lage. Tai ke 1 banabo lage. To ki koribo ami neighboring row do na lagibo. Ki koribo tai 0 hoise already. To tai ke ki koribo multiply by 1 by 2 kori dibo or divide by 2. So row 2 goes for row 2 upon 2. This will be now equivalent to 3 minus 1, 0 upon 2 is 0, 2 upon 2 is 1. Same operation has to be performed over this matrix. 1 0 4 divided by 2 2 and then 3 by 2 with okay into 이다 도 row 1 돼 이거 row 1 나가 entry도 이도 बना볼래 लागे तो first की 그리고 군도 그리고 이도 entry도 row 1 나가 이도 -1 entry도 0 बना볼래 लागे तो 이도 0 बना볼래 निमित्त हामी खान neighboring row चलाबोदो तो row तो चलाबोदो तो ताइला corresponding element साबे ना ताइला corresponding element 1 आसेदो तो ताइला की operation करि दिले 0 হৈ যাব row की करिवो yeah r1 plus r2 do r1 दे हालि दिबो ना so r1 goes for r1 plus r2 तो सस्तो गे मेथड पर शिकले न बुझिबो दे तुमी जन हौरा बुझियासे दो तो किन होबे दो all the elements of r1 will undergo this transformation 3 plus 0 3 minus 1 plus 1 0 yeah no changes right is equal to the same transformation on the right side over this matrix 1 plus 2 is 3 0 plus 3 by 2 I'm just setting the corresponding element only right 0 plus 3 by 2 is 3 by 2 and there are no changes here 2 and 3 by 2 times a now what else I'm going to convert this entry as 1 so it's already this is 0 so I have no problem so yeah r1 goes for r1 upon 3 so this becomes 1 0 0 1 and this becomes 1 1 by 2 3 by 2 divided by 3 is 1 by 2 2 and 3 by 2 with a times a now this is your therefore this is your now identity matrix this is any matrix AB so 1 1 by 2 2 3 by 2 into a so it will be asido so BA is ido na so this implies A you can transpose it as A inverse is equal to 1 1 by 2 2 3 by 2 so this becomes A inverse is equal to 1 1 by 2 so A inverse exists and it is equal to this matrix all right